Okay, this is the third video on simulations, or and the third simulation that we're going to run. And once again, I'm going to use some pre-printed answers to speed things along. A certain professor, and this is page 10 of the notes spiral, excuse me, page 10 of the notes spiral. A certain professor has 8 keys, but he never recalls which one fits his office door lock. He places all of the keys on the table and randomly selects and tries one key at a time. If the key does not fit, places the key back in the original pile. Why did he do that? Because he's an idiot. And then randomly selects another key. Yes, he's senile, probably teaches stats. Don't laugh, please. That'd be kind of rude. Not all the key. Note, all the keys look the same, and he's unable to tell which key he has already tried. Conduct a simulation to answer the following question. Use the random number table below and conduct 20 trials. Well, real quickly, I sit there and go, I don't have 20 rows, so that means I'm going to have multiple trials on a row, okay? Clearly identify each trial on the table. Explain how you would conduct a simulation using the random number table below. Provide the estimate number of keys the professor would need to try. So basically, we have a professor. The story is he has a professor. He has a stack of keys. He doesn't know which key fits the lock. He can't ever remember. He tries one key, then puts it back in a pile and draws a second key. Problem is, because he can't tell them apart and he put them back in the same pile, he can draw the same key over and over again. All right? So consequently, in this case, duplicates are allowed. The component that we're trying is we're trying a key, and we're going to continue to try a key until the lock opens. Now, because he's putting it back in the same pile, it's possible he'll never find a key that opens the door. Now, first off, we have 8 keys. So if we have 8 keys, we probably should be working with single-digit numbers. All right? So I'm going to make an assignment using single-digit numbers because that's easier than 2-digit numbers. And once again, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because we have 8 keys, I'm going to say 1 through 8 represent keys. But the key that opens the door, I chose number 8. You can choose any, once again, you can choose any combination and you can choose which one works. But I'm going to choose key number 8, and so I suggest you do that the same for this. So I'll work left to right, choosing single-digit numbers. 1 through 8 represent actual keys. Digits 9 and 0 are skips. If you have them, you have to address them. We do have 2 numbers that don't count, as they do not represent keys. Key number 8 is the correct key for the lock. Because keys are replaced, duplicates are permitted. All right, that's kind of important. Because the keys are replaced, duplicates are permitted. A key can be tried multiple times. You don't have to include that, but I want you to remember that for this. That's definitely not necessary. The trial will end when I find the correct key. So we addressed when the trial ends, and we're going to run 20 trials. So I start off running this thing. Wrong key. Got to the correct key. Wrong key, got to the correct key. So I continued doing that, okay? So this one took 3 keys, and I'm ranking a little table off to the side. This one took 4 keys, this one only took 3. Now look here. A wrong key. I marked an X as a skip. It just didn't count. You probably can't see it really well, but there's this right here. 9 did not count. It's a skip. Wrong key. Here's a skip. Wrong key. And by the way, if you've noticed, I've already had a 6 occur and a 6 occur, but remember, duplicates are allowed. So we can try the same key more than once in this particular scenario. Wrong key. There's another duplicate. Here's the duplicates. So we have all these duplicates. Duplicates were permitted, but remember the skips are not. So the 9 and the 0 are not permitted. All right. When I count up everything that was not a skip, I find out he tried 13 different times in the first trial. Over here, wrong key, wrong key, wrong key, wraps around. Number 9 happens to be a skip, and I end up getting to 11 keys. Okay, so this was what this actually looked like. I'm going to put this up on the screen so you can kind of see it, and you can pause it and write that down. And when all said and done, he tried 137 keys. Well, he did that for we repeated this thing 20 times. So on average, we'd expect it to be 6.85 keys. So part B is, what is the expected number of tries needed for him to find the correct key? Based on the simulation below, we would expect the professor to have to try an average of 6.8 keys to find the one that fits the lock. All right, what's the probability that it'll take more than 4 tries? So I need to sit there and mark all the ones that take more than 4 tries. Not more than 4, not more than 4, not more than 4. The ones here in yellow are the more than 4 tries. All right. So 11 times out of 20, it took more than 4 tries. I'm sorry that the skips don't show up better, but if you pull up the notes on the pre-printed notes, I think they will show up better on the pre-printed notes. Hopefully that helps you out. Thank you.